Then next is multi-level queue. So ready queue is partitioned into separate queues for foreground processes and background processes. So we can put interactive processes into foreground queue and batch processes into background queue, because background processes are those processes which do not require any intervention of the user, or which does not require any user support, right? So those processes can be submitted in the background, and the processes which require some user input or some interaction from the user, those can be submitted to the foreground queue, right? So each queue has its own scheduling algorithm. It can be round robin, FCFS, priority, SAF, anyone, and scheduling must be done between the queues. Fixed priority scheduling, that which queue is having the highest priority, which queue is having the lowest priority, or we can execute, or we can assign them some time slice according to their priority, that highest priority queue will be executed for 80% of the time, and for 20% of the time your background processes or the lower priority queue will be executed, right? So like this we can have multiple queues with our system, and within queue we can assign some scheduling policy, and between queues again we can assign some policy that for how long your highest priority q1 will be executed, and for how long another queue of low priority will be executed, right? So this can be one example in which we have 5 queues in the system. So whenever a system process will be submitted to the ready queue, it will be submitted in the highest priority queue, and interactive processes will be submitted to second highest. Interactive editing processes may be submitted to third highest. Batch processes can be submitted to fourth highest, and student processes can be submitted to the lowest priority queue. The point here to note is that a process will remain in the same queue in which it has been submitted initially. A process is not allowed to change the queue once it is submitted to the system, right? So in this case we have highest priority of the system queue processes, then interactive processes, then interactive editing processes, then batch processing, and then student processes. Now it is not fixed that we should have the priority in this order only. It totally depends on your operating system implementation. For what purpose you are trying to implement the operating system, for what purpose, or for what objective, or what is your target audience you are trying to target, it totally depends on that, right? So it is system dependent that which queue or what processes will be submitted to which queue with highest priority, and which processes will be submitted to the lowest priority queue. So among these queues we may have some policy that how these queues will be submitted into the CPU, and within a queue what will be the scheduling policy. So a system processes can be executed in FCFS manner, interactive processes can be executed in round robin manner, interactive editing process can be executed in some priority scheduling, batch processing can be executed in FCFS, or student processes can be executed in the priority order or SAF order, right? So there may be different policies for each queue, and among these queues there may be some policy, so that we can decide that which queue will be executed for how long. right? So this is the multi-level queue scheduling. We have divided our processes into some categories, and according to their priority we can assign them some queue, and these queues are also having some order of their priority, right? But again, the point here to note is that a process will not be allowed to change its queue during its execution. The process will be remain in the same queue in which it was submitted until its termination, right? So again, there may be issue of some starvation in this case, that the lowest priority queue will never gets executed, right? So to solve this problem,